Good morning. Recap on what we did yesterday. We used the method of taking logarithm. In this case, we take a natural logarithm on both sides. And then we just carry out the operation using power rule, combining like terms, right? And then do some algebraic operation, right? And then in the end, we got the solution. But today I wish to show you the algebraic perspective of it, right? Like what we did with quadratic, right? Remember when we were doing quadratic? When we were doing quadratic, we were talking about these crossings, right? And in this section, we also talk about the method of graphing, using graph to solve, the equation, right? How is this idea placed in our current situation? So what I did is that I graphed these two curves, okay? So this is these can be easily graphed using your calculator. So I'm not going to go into the lenses. So this is a 2 to the power. Hold on, I should be using a different color if I can help it. So this curve is 2 raised to the power of 3x plus 1. Okay, that 3 is a bit ugly. 3x. Okay, 3x. And the red is, of course, is 3 to the power x minus 2. Okay, these two curves has a crossing. But you see the scale I played with, right, before the class, and you see the scales I played with. The scales on the y coordinate is exceedingly small. Well, relative, it's a 0.01, because if you use a normal scale, you're not going to see it. It's hard to see. And so this is the point of intersection. So the x value we found, which is a -2 times natural log 3 minus natural log 2, excuse me, divided by, so let me get the fonts a bit larger, right? Divided by 3 times natural log 2 minus natural log 3. And this is the input. Okay, this is the input. This input is a little bit less than -3. Okay, it's about here. Okay, so let me show you. It's about point over here. Okay, not a -3, but a little bit closer. It's very close to -3. And the 3 to the power of that number, so it's right here, the point of intersection. Okay, so what a method 2 can do us, even though we still cannot identify the precise value, but the true, purpose, oftentimes using function method is when we want to identify or we want to decide if the solution does exist. Okay, and of course, certainly it does exist in this case. So there is a crossing, and the crossing is where, the x value is the x coordinate, the input value at the crossing. You follow me? So number 19, if you look at the perspective from functions perspective, right? For this example we did, it's just, you know, it is a horizontal line, 3 to the power x, and there's a horizontal line. In our case here, right? In our case here, if you put it over here, right, it's the crossing between the two curves. Okay, so let me write it down. Crossing between curves. And these two curves are these two, respectively. You follow me? So if I put this in the picture, okay, I'm gonna put it over here, okay? And of course, this should be relevant to substitute all of these. So we look at these different perspectives. Sometimes these different methods, they do have different purposes. And I wish I give you all these methods because I want you to be using them flexibly as you need. I wouldn't know what you're going to what you're going to need in the future, right? There will be situation, but all 4 methods should give you enough, right? So in this case, it's the crossing between these two curves. It's a crossing between these two curves. Does that make sense, you guys? And this method is used a lot, especially when solving the equations algebraically is difficult. And sometimes it's impossible, okay? Sometimes it might be impossible or algebraically difficult to do, okay? So crossing, so let me use the word X, right? Like the crossing you see on the street, right? Crossing between, so let me make the word just a little bit shorter so that we can you know, have more in this picture. Solving by intuition here is a little bit difficult. It's a little bit difficult. It can still be done. Okay? You can use definition, but no matter what you do, you have to do something a little bit unusual to see, But if you can manage, you can still work it. For example, right? In this case, I would go by definition. In this case, number 1 and number 4 actually could be combined. Number 1 and number 4 can be combined. Okay, what do I mean by this is that in the definition, okay, so this is solve by graphing. Okay, solve by graphing. Graphing tell us is it possible to have a crossing? But it's difficult to identify the precise value. It's difficult to identify the precise value. So we still have to rely on the algebraic means to identify the value. You follow me? But now, suppose I'm going to solve it by, so now I can remove this, right? The crossing, I'm going to remove this. So the crossing is, hold on. I want to keep everything for you. Okay, so I don't want to delete anything. So you can put it together. Okay, the crossing, this is the crossing, right? This is the crossing. It looks rather complicated, right? But it's just plugging numbers and sort. Okay, so this is the graphing, okay? The pro of graphing is that we can determine the existence of a solution or solutions. the cons. What is the cons? Right, the pros and cons. The pros is we can determine from the picture, we can tell, oh, there is a connection. We definitely have solution. The cons is hard to identify the precise value. The precise values of input and output. Okay, but oftentimes determine the existence is very important too. All right, so let's do method 1 and number 4 combined. Okay, because in this case, the intuition, it would be rather complicated, right? It will be, say for example, could I express this number in terms of, you know, something we did before? Remember what we did before, right? By intuition, with 3 to the power x equals to 5, remember? And what did we do with 5? We express 5 as 3 raised to the power of what? Log base 3 of 5, right? Remember we did that? We could totally do something similar here. Yes? We could totally do something similar here. But that's still not going to solve the question. It's still not going to solve the problem. Okay, so we could do something like this. So I'm going to bring this over here. So we have more space to work with, right? We could do something similar to here. Do you follow me, you guys? Do you guys follow me? This gets a little bit more complicated as using logarithm. Do you have to know this? Well, I think it will greatly enhance your algebraic skill. Okay, it will greatly enhance your algebraic skill. Okay, so what you can do is that we can imagine, you know, you can say, okay, 2 raised to the power of 3x plus 1 equals to 3 raised to the power of x minus 2. What I'm going to do is I'm going to view this guy as triangle. Okay? And this triangle would be equals to 2 raised to the power of log base 2 of triangle. And what is triangle? What is triangle? Triangle is this guy, right? So we continue. We continue, right? And that's our triangle. So triangle is placed here. Do you see that? But this doesn't feel like a solving because you're actually getting question more complicated, isn't it? You're actually getting you know, the process more complicated. You can continue. Okay, let me, I'm not going to spend too much time here. Okay, so we end up with something like this. Okay, something like this. Same base 2, therefore 3x plus 1 is equal to what? This exponent. Exponent equals to exponent. And then you're going to bring the power down. You're going to get log base 2 of 3. So now what you do? Okay, now what you do? You have an x here and you have an x here. If you do straight method number 4, you also get here. Okay, it's just different ways of doing it. I try not to spend too much time here. but I still want to give you some kind of guideline because a lot of our student tends to go this route. A lot of our student tends to go this route. What they do is that they, for example, they may not be doing this. They will take a log base 3. Okay, so let me finish. Okay, let me finish this, and I will show you the method 4, what it leads to, right? Even though I personally doesn't want to distract you guys to this way, because it's just it just seemed to be more complicated than it should be. But it was interesting. A lot of our students, when I grade their work, I hope this is not going to be you guys, but I want to prepare you for that situation, just in case you get into this situation. Okay, a lot of our students will get themselves to this position by taking logarithm log base 2 or log base 3. They get to a similar situation, okay, which is a method 4. And they get here and they're lost. They get here, they're lost because they see the X here. They say, what am I going to do with it? Actually, no big deal. You actually on the right track. You are on the right track. What do I mean? You just take this X, multiply that, right? So take this X, multiply the log base 2 of 3. Okay, that's one single number, don't separate it. And minus 2 times log base 2 of 3. Oops. 2 times log base 2 of 3. Do you see that? And then you're going to bring the x's together. Okay, so you're going to subtract this guy on both sides. Subtract this guy on both sides. Okay, subtract 1 on both sides. As I said earlier, I don't encourage you to show me this stuff. It's often very messy. I don't need to see this. Okay, I don't need to see these. Okay, what I would do, I will go straight to 3x minus this guy, right? And that is equals to negative 2 times log base 3 minus 1. Okay, so on the right-hand side, that's what it is. Okay, so now the x's are together. And terms without x's are separate. They're separated. And factor out the x. Factor out the x. Right? So you have 3 minus log base 2 of 3 equals to, and the entirety of the right-hand side. So I'm just copying and paste. In the end, you divide both sides by the parentheses, and you get a different looking solution, but it is still a solution. It is still a solution. And this solution is going to yield the same answer. It's going to yield the same answer as the other one. In fact, if you do change your base formula, you're going to get the one we got on the first time. Okay. So next, I want you guys to review these steps. Okay, I want you guys to review these steps. Okay. So this is addressing method 1. Method 1 as the so-called by intuition. It doesn't seem to be that intuitive anymore, right? It doesn't seem to be that intuitive anymore. But this will coincide with method 4. Okay, method 4. And this time I want you guys to try your hands on it. Okay, so what I can do, what I will ask you guys to do, okay, practice this, okay? You use method 4, okay, your choice. Take logarithm, take logarithm of base 2 or base 3, your choice. Please try. Your time, your turn. You take a logarithm. I'm sure some of you are trying that. And I want you to understand what as earlier I said, there's a trap some students get to, okay? When they solve this kind of equation. I don't want you to go there, actually, but I always see that. I always see that, okay? So I want to give you a couple minutes to try it. I'm gonna just get something to drink. I'll be right back. Okay, so try
I think your mic is muted.
Unmuted. Thank you. Um, so where are you? Method 4, we're using definition, right? We're using definition. So when you're using definition, you can, there are two ways to see this. If you take log base 2, right? If you take log base 2, right? So if you decide to use this as the exponential part, and then you can treat this piece as a triangle, right? You can treat that piece as a triangle, right? So you're going to end up with what? You're going to end up with what? 3x plus 1 equals to log base 2 of what? Maybe we use omega. Let's see. I think using omega is more of the symbol you're used to, right? Yes. It shouldn't matter. It shouldn't matter. I use triangle or omega, but here I'm using omega. Do you guys follow me? But this omega is really what? It's really long. It's this omega is really this guy, right? And then you're gonna bring the power to the front of it, and then you're gonna have a log base 2 of 3 right there. So you're getting exactly where it was here. You follow me? Yes. So you end up here. So you're ending up with everything here, right? So this is where we end up with, right? And you go through the steps so that we did earlier. You go through the steps, right? You go through the steps and you're gonna get the same answer. You're gonna get the same answer. Do you follow me? So using method 4, that's what you can do. Okay. Any one of you have tried using base 3? Anybody tried using base 3? Okay, so how about I show you using base 3? Right? I'm gonna show you. Yeah, you're gonna find that these methods are similar in nature. Okay, so suppose I'm using base 3. Okay, so here we're using base 3. Okay, so there is base 2. We use base 2, and here we're using base 3. Okay, when we use base 3, so what's going on? When we are using base 3, this guy is omega. Right? So you're getting what? You're getting x minus 2 equals to log base 3. I'm using definition. Do you follow me? Do you guys follow me? Okay, I'm using definition. And of course, this is log base 3. And omega is this guy. It's similar, isn't it? So it doesn't matter which one you use. Eventually, you're getting to 3x plus 1. And then log base 3 of 2. So that's where you end up. That's where we end up. Okay, if you trim everything in between, that's what we get. You have x here, you have x there. Okay, you have an x here, you have an x there. Okay, and what you do? What do? You will distribute this guy to the inside of the parentheses. So you have 3 times of x log base 3 of 2 plus log base 3 of 2. Okay. And now we're going to bring the axes together. How are you going to bring the axes together? You can bring them to the left, you can bring them to the right, but the key point is you're going to separate the axes, right? You're going to separate the axes with the term without the axes. So suppose I'm going to move the axes on the left-hand side. Okay, so I'm subtracting this guy on both sides. Okay, on the other side, I'm subtracting the same thing, right? And I'm adding 2 on both sides. All these are pretty common algebraic manipulation, right? And u plus 2. As I said earlier, I don't want to see this. These are typical on the scratch paper, okay? So you don't need to show these to me. Okay. This piece, I'm showing it to you because a lot of you guys like to know this. No need to show. Okay. So, and now what do we get? Okay. So we get x minus 3x times log base 3 of 2 equals to log base 3 of 2 or 2 plus log base 3 of 2. Okay. And on this side, you're going to factor out the x. Okay, and then you get a 1 minus 3 times log base 3 of 2. And equals to the entirety of the right-hand side. And then divide both sides by the parentheses. Divide both sides by the parentheses. So this is in the denominator. Okay, and that guy is in the numerator. Different looking solution, isn't it? Different looking solution. Are all these solutions the same? Absolutely. You can convert one to the other using change of base formula. Using change of base formula, you get them to the same place. You get them to the same place. Okay. Why do I encourage you guys to do this? Okay, the last 2 methods are often not what I promoted, but I always see students get into them. Okay, because this question I have tested, put it on the test, on the quiz many, many times. And I always see this phenomena. I show the classes, you just take ln or take a common log on both sides. But for some reason, it doesn't seem to be received by all the students that way. The student have the tendency to do either base 3 or base 2. Okay, base 2 being more popular. Okay, and then they get to this point. No, they get to this place. Okay, get to this place. The common mistake happens here. The common mistake, the common trap, I would say, common trap. What's a common trap? Student get here, okay? They will do this. They will subtract 1 from both sides. Okay, this is the common trap the student get into. Okay, they will subtract 1 on both sides and divide both sides by 3. This is one of the common traps. This is unfinished. This is, I'm calling this a trap because this is unfinished. Do you follow me? This is unfinished. Why is unfinished? If you've done this one, you're not wrong. You're not wrong. You're not wrong. It's not finished. Why it's not finished? Because there's X here. Okay. And there's another trap a student get to, which is from here, right? Similar. Common trap. Okay. This student will take this one, adding 2 on both sides. Once again, you're not done. You're not finished. Okay, so not finished. So this is my report to you, okay, which I have indicated all these traps. Now you have seen all these methods. Which one do you think will be more preferable for you? You don't have to agree with me, okay? You don't have to agree with me. Which one is more preferable to you? Now, did you write them down? Because if you haven't wrote them down, I want you to write it down step by step because you need to practice on these. Okay, practicing on these will greatly enhance your algebraic skill. Enhance your algebraic skill, which you need very much. Okay, so this is the opportunity to enhance your algebraic skill. I pointed out the traps. Okay, I want you to take a complete notes. Now you have that notes in front of you, including the method we talked about yesterday. Which one is in your favor, do you think? If you can give me a feedback today, that's great. If you don't want to tell me today, that's fine also. So you are the one that's, because every way you get to Rome, right? You can get to Rome in every way, even though you get different looking answer. You get different looking answer. All those answers are the same if you use change your base formula. Okay, now the question is your assessment. Which one would you prefer? There's no right or wrong answer because every way will get you the answer. The other thing I wish to mention to you is that by doing this particular question, Mikhail says he prefers the common log way. Yeah, that's great. No problem. So we haven't done the common log way. Did you guys do it yet? We're going to do that way together, okay? I like that proposal, Mikhail. Okay, because common log is the most common button on every calculator. We should do that, okay? I did the natural log way, so we should do the common log way. Mikhail, did you do it? Did you do the common log way yet? Yes, no? You can tell me later. But when the whole class is gonna do common log way. Oh, you prefer the natural log way. That's okay. He likes the natural log way. I'm not trying to push you guys to any way. Okay, got it, Miguel. I appreciate that. We're gonna do the common log way together, okay? Because I as I said earlier, I have given this question as exam questions for years, Same question, no change, no change. Okay, oftentimes I give the same question. You know, I went over all these things in class, and I was pushing the natural log way, the common log way. Okay, I didn't do very much of this way. Okay, I didn't do the log base 2, log base 3 way very much in classes at the time. Okay, if I think back in the past 3-5 years, I was giving this question on quizzes, exams. Many times, many times I mean that it could be 3-5 times for one class during the semester. But I always have students they will have the tendency to go to the, excuse me, the common log, the log base 3 or log base 2 way. I always have students do that, no matter how many times I address the natural log way. I don't know why. I don't know why. My other classes, you know, sometimes I have 2 pre-calculus classes in one semester. So I have lots of students that tend to go to those ways. I couldn't understand. I couldn't understand why. After I have done the promotion of natural log way or common log way. Okay, it's something I don't understand. If you can help me to understand that, and give me some, you know, some hint about your whatever you observed, I would like to know. I would like to know. This is the reason why I was trying to address this question thoroughly. And in the process, okay, I gave this question to many students. You can see I gave this question to hundreds of students in the past. So I have graded the work of hundreds of students. I mean, grading it, you mean, I look at the steps. What I found that these students are terribly lacking in algebraic skills. You follow me? I mean, those other students, I'm not saying you. They terribly are in need to improve their algebraic skill. So now I'm making a call to action. I'm asking you guys to try to improve your algebraic skill. And these steps are better, you know, a good situation for you to practice that. Okay. Anyway, without further ado, so let's do the common log way. Let's do the common log way. Okay. I'm taking common log on both sides. I can because both sides are positive, right? Common log way. And the left-hand side, 3x plus 1 and log 2. And the other side is x minus 2 log 3. I'm going to let you guys to carry out the steps. Would you do that for me? Go ahead. Just run to the finish. Okay, just run to the finish. Okay, treating log 2, log 3 as a single number. Okay, log 2 is a single number. Log 3 is a single number. Don't separate them. Just treat them as one number. This is just one number. One number. Okay, it's just one number. Get used to it. Okay, you must get used to these. Anybody want to show your work? Got it? Bailey, good job. All right. So let's examine his work. Thank you for sharing that, Bailey. Looks nice. All right. Okay, so now I pretend I'm grading his work. Okay. He took logarithm on both sides. Okay, very good. Parentheses in place, perfect. Distribution, excellent. Look at that, it's beautiful. This is a beautiful work, okay? Subtracting, factoring out, parentheses in place. Perfect, perfect. No correction to be made. Perfect, very good job. Anybody else? You can see the log way is the same thing, right? Common log way is similar. So in this situation, when you have two different bases involved, it might be better you choose either common log or natural log. If you do it, if you just keep doing this, look at what a beautiful job he did, right? Every one of you can do this. Every one of you can do this, or you can use natural log, okay? I have prepared the quiz for you, and you will see the quiz. You should have seen it already if you know, there's 3 attempts. And one of them is about this question, because it's a different aspect of this question, okay? Anyway, without further ado, do you guys want to try number 20? Number 20 is a little easier, actually. Okay, but I want to give you a chance to practice that. Okay, thank you for sharing, Bailey. That's a beautiful work. Okay, so please try number 20. Okay, I'm just going to finish this up. Okay, I'm just basically copy, you know, Bailey's work. Good job. Okay, so you guys try number 20. Twenty. If anybody want to show your work, please do. I encourage you, all of you submit your work. Okay, don't be embarrassed. I hope you're brave enough We are in the land of free and the home of the brave, right? Please be brave. Show your work. We are on this land of, we call it the land of free, the home of the brave, the home of the brave. Is that right? Show your work. Show your work. I'd love to see your work. Serious. I'm serious. Did I see some work? Yeah,
I sent mine, but I'm not sure if it went through or not.
I see it. I see it. Okay. So for those of you who wish to submit, it's still not late to submit. I'm just going to go over whichever one that's been submitted and critique. Okay. You don't mind my criticism, do you? I'll critique your work, but I don't criticize you. Okay. You are my favorite students. I won't criticize you. I'm just trying to help you to examine your work. Okay. So please don't take it personal. Let's share this screen. There you go. All right. So he's chosen the natural log. Okay, that's good. We can take logarithm because both sides are positive. Half of x is over here. It's brought down by the power rule. Okay, very good. And half of x is natural log to 7. And on the other side is 1 times ln 5 minus x times ln 5. Very good. Okay, all this is good. And then he bring the x's together. I would think that this would turn to a positive. Right? That would turn to positive. And then this will be positive. And what he did, which I like, he multiplied both sides by 2. Okay, I like that very much. But he missed the 2 over here. You see that? If you multiply by 2, you multiply by 2 on this term, you also need to multiply by on this term and that term. You multiply by 2 on this side. That's okay. But this 2 is missing, it should be plus 2. Okay? You see that? And over here, so this is going to be plus 2. And this is a good. This is good. The factoring is good. Dividing is good. And this piece need to be modified. Does everybody follow me? So plus 2. All right. Anybody did a common log or log or base anything else? Okay. All work are welcome. All work are welcome. So please do submit. Okay, very good job, Bailey. Okay, you see, he showed his steps very clearly. He showed his step very, very clearly. Even though there's a minor mistake, but the mistake, it shows consistency. So this consistency, the mistake here, you're gonna lose a little bit point, but not too much. Because in between, based on that mistake, you did everything right. So you probably missed 1 point in this case. Okay, so if you make your work very easily to be read, okay, very easy to assess your work and very easy to identify the mistake, and the point to be taken away from that mistake is usually just fixed. It's not going to propagate. It's not going to propagate. So you will only be taking points off for what mistake? For 2 mistakes. One is this should be adding, and the other one is missing the multiply by 2. I would say, yeah, probably 2 points off. Probably 2 points off. That's it. This could be easily like a 10 points question or even more points. Okay, so in that regard, you don't miss very much, but I can also assess that you got it, right? These are the mistake we call a minor mistake, even though they're still mistakes, but it's a minor mistake. Okay, all right. So anybody else who would like to submit, okay, I hope everybody will learn the lesson from this mistake, from these mistakes, right? He multiplied by 2, which is a great move. You have to make sure you multiply by 2 on every term, Okay, good job. Next, do I get to see a next? No? Okay, I'm just going to copy Bailey's work. Okay, if there's another submission, I'll be happy to see it and grade it. I think you guys start to like the Ellen, right? Is that right? Are you getting do you think you're getting more and more used to Ellen? Natural log? Yes, I think so. Okay, it just you have to use it. It's like driving, right? You just have to get used to it. Multiply by 2. And factored out the x. And finally, x equals to, this piece is in the denominator, and that piece is on the top. Okay, had you taken common log on this, you get a similar result. you get similar result. Anybody want to submit your work on common log? Yes, no? Where's everybody else? Ivan? Mikhail? Andy? Cortland? No? You're good? Okay. So can we put this section behind us? Okay, so let's do that. Okay, I'm gonna put this section behind us. And we're gonna move on to, of course, to practice this, I mentioned yesterday, you can practice EXP1B, EXP1C. There are lots of exercises there for you to practice until you get really, really good, okay? Let's look at EXP2, EXP2, okay? I suspect I made some changes to EXP2 from my older version. I have a hard copy of my old version of EXP2. Hold on. Okay, I'm gonna put it on the other monitor. I just want to double check because I think I might modify the notes a bit. Okay. Keep working on what what you're doing. I should rearrange my notes in such a way, make it easier to get to the pages I want. Maybe a Google Doc or something. Okay. EXP1C passed. Yeah, let's look at EXP2. I figured I made some changes. Right? Okay, I made some changes. Transformation again. EXP2. Are you guys there? Are you guys there? This is on notes number, page number 82. Page number 82. You're probably already there. Okay. EXP2. It's about transformation. Of the exponential function. We have done the graph, right? We have done the graph. We have done the graph of 2 to the power x and e to the power x, didn't we? Right? We've done those. And you can keep going 3 to the power x, 3 to the, 10 to the power x, and so on and so forth. So let's look at these shifting. Okay, let's look at the shifting. Shifting, reflection, and so on and so forth. Okay. So in order to observe all of these shifting, vertical shifting, horizontal shifting, etc., I made some group exercise for us to do together. Okay, I made some group exercise for us to do it together. The first one would be f of x minus 1. So I basically chosen c equals to 1. I basically chosen c equals to 1 in the first and second case. Okay, so let's look at this this situation. Okay, the first one, 3 column, right? So we're doing f of x plus 1 minus 1 plus 1. Right? In comparison, the second one would be still be f of x f of x. One is f of x minus 1, f of x plus 1. What's the difference? Minus 1, minus 1. Outside, inside. What's that difference? Can we tell the difference?
When it's outside, it's vertical, and when it's inside, it's horizontal.
Outside is vertical. Could you say it again? Could you type it on the, it's a very good comment. Can you put it on the chat? Oh, Andy, I'm so sorry that I think you probably refer to number 20. I did by definition, don't know if it's right. If you want me to check, I would check for you. I'm so sorry, I missed that part. Bailey says outside is vertical, inside is horizontal. That's a very good comments, okay? But also from the perspective of input output, it's okay after lecture. It's okay after lecture. Okay. Okay, of course. Okay. So you are absolutely right, Bailey. But however, I do want to give you that perspective, right? Because oftentimes our students get confused. What do you mean? Subtract 1 here, subtract 1 here. What's the difference? No difference. Well, there's a big difference. There's a big difference, okay? From the perspective of function, okay, from the perspective of function, then just to confirm Bailey's comments and from a different perspective, is that you have this function that takes the input, it produces the output. So the output is produced, and then this output is going to be taken and subtract 1. So one is output subtract 1, and the other one is what? Input subtract 1. Do you follow me? That's the difference. That's the difference. Do you follow me? So that's the difference. That's the primary difference. Okay, so one is subtracting 1 on the output. The other one is subtracting the output, subtracting the 1 before the function is acting on the input. So you subtract 1 on the input. Of course, that's different. Of course, that's different. Okay, so we want to see that difference firsthand. Do you follow me? Now, we're going to do one at a time. We're going to do it one at a time. Okay, functions perspective. The first one, We did similar things with quadratic, didn't we? Remember, we did similar thing with a quadratic. Okay, so let me review this. Let me review this for you, okay? If f of x is x squared, yeah? What would this be? This will be x squared minus 1, and this will be x squared plus 1, right? Did we do those? Did we do, if this were x squared, and this is going to be what? X minus 1 squared? And that's going to be x plus 1 squared, isn't it? Remember we did this before? Okay, so now is a turn about, let's do 2 to the power x first. 2 to the power x often is easier. You will see they are similar in nature. Okay, they are similar in nature. So 2 to the power x minus 1, 2 to the power x plus 1, 2 to the power x, and 2 to the power of x minus 1, 2 to the power of x plus 1. You follow me? When we were doing for quadratic, do you still remember these 3 pictures? This one, these 3. Can you guys just sketch those on your paper? If you want to share with me, I'll be happy to see it. Hmm? I just want to bring back some pictures, okay? You guys just do your drawing. You guys remember these? X squared minus 1 is the red, right? X squared minus 1 is a red. X squared plus 1 is the green, right? And the black is the x squared. Okay, remember that? Okay, and we will see the similarity. In fact, the ideas are all the same. That's That observation, okay, will help us to understand that they're similar. The same for sine, for cosine, tangent, and any function you can name it. Okay, and you also see the power, we introduce this notation. We introduce these notation. We introduce this notation, and I want you guys to use this notation. It's a powerful, beautiful notation, very, very resourceful. It can give us a lot of information. It can give us a lot of information. Okay, so are you guys with me? All right, so let's look at the second curve. Okay, just to review. Okay, x squared is the black, right? And the red is, what is the red? The red is x minus 1 squared. And the green is x plus 1 squared. Agree? Is that what we did? With that behind us, we're going to work on 2 to the power x and the shifting. Okay, and the shifting. And we'll see what we get. I hope at the end of it, you're going to tell me, oh, it's so easy. And I'm sure that's what you're going to tell me. Okay, we have 10 minutes left. Let's move on. Let's move on. Here we go. Okay, we do one at a time. You can see already, okay, from functions perspective, and when this is a 2 to the power x, right? So this is a 2 to the power x, and this is 2 to the power x minus 1, right? Of course, that's 2 to the power x plus 1. But this one, however, this is 1 is forever, however, and this will gonna give us 2 raised to the power of x minus 1. Do you see the difference? 1 is 2 to the power x minus 1. There's an order of operation there, and this is 2 to the power x minus 1. The order is that for this case, you're going to do the power first and then subtract 1. In this case, you're going to do the exponents first and then do the exponential. You see the difference? Okay, so now we're going to do one at a time. I think we cannot finish all of it today, and you could continue to do it tomorrow. So let's look at some points. Okay? And with regard to this, I'm just gonna, for a completion of that, so this is a plus 1, okay? This is a plus 1. And of course, for this one, it's just a 2 to the power x. Okay, so that's the function perspective. So let's plot some points. Okay, we are pretty familiar with that picture, don't we? Okay, so once again, I'm going to give you the points for you to plot. Okay, so for the x value, for the input, okay, I will give you -2, -1, 0, 1, 2. The function here in consideration is going to be 2 to the power x. And the points, input, comma, output. Okay, of course, input x, you know. The second picture you're going to do is that 2 to the power x minus 1. The third one you're going to do, through this exercise, okay, easy exercise, you get an intuition. we get intuition. We get the right kind of intuition. We get the right kind of intuition. Okay, that's how intuition are built. Okay, that's how intuition are built. Why do I get this? Okay. Oh, sorry. Do you guys have those? Do you guys have the table with you? Okay, I'm going to use the right notation. Okay, so here I'm going to do f of x minus 1. Here I'm going to do f of x plus 1. Okay, I want you to get used to these notations. Okay, they're very, very helpful. Or at least from my personal experience, it helped me. It helped me. Okay, but it takes some time to get used to it. Okay, I know that it takes some time to get used to it, but you will. Okay, so this is going to be 2 raised to the power negative 1. Okay, 2 raised to the power 0. 2 raised to the power 1. 2 raised to the power 2. Okay, so all of these is going to come here. Minus 1, minus 1, minus 1, minus 1, minus 1. All of these are coming here. So you see clearly they're adding or subtracting 1 on the input or output. In this case, it's on the output. And the points okay, so this is a negative 2 quarter, and this is a negative 1 half, 0, 1, 1 comma 2, 2 comma 4. And all of these is transported, but only the output is subtracted by 1. We'll do that. We'll carry out the operation. We'll simply, I will ask you to simplify the numbers, but right now I want you to write down what I wrote down exactly. Do you follow me? Okay. After the power, subtract 1. After power, adding 1. So it's been reflected on the output alone. If the input don't change, the output, only the output changed. See that? Only the output changed. Input didn't change. Okay, so that's why you're going to see the vertical shift. Remember the comments Bailey made on the chat, right? Outside is vertical, inside is horizontal, right? Outside means that after the output, you increase by 1 or decrease by 1. Inside means what? The input is shifted first. But input is horizontal, right? Input is horizontal. So that was very, very helpful comments. Very, very helpful comments. And then you just plot points, okay? And of course, this one is going to give us what? -3/4. Right? And this is going to be -1/2. And this is going to be 0. And this is going to be 1. And this is going to be 3. Okay. So from 1/4 to -3/4, that's a shifting down by 1 unit. You guys with me? These two numbers, the difference is 1. These two numbers, the difference is 1. These two numbers, the difference is 1. This is the vertical shift. You guys see that? The vertical shift is reflected on the output. And it's also reflected right here. Subtract 1. That's the effect of that subtracting 1. Do you follow me? Well, our time is up. Okay. I want you guys to finish the table and plot the points to see for yourself. You will find out this is similar to what we did with x squared. That's the point I want to make here. Okay, that's the point I want to make here. So you don't need to memorize. Do you think you still need to memorize? Do you need to memorize anymore? Cortland, Mikhail, do you think you still have to memorize all these different things, inside, outside? Do you need to? Evan, Mikhail, Sergio, Cortland, Baby, Andy, do you think you still have to memorize these things? Not anymore, I hope. Not anymore. That's the magic of doing it by yourself. And it will have that magical effect. You don't need to memorize. You see it with your mind's eyes because you have done these groundwork. Okay, it's like Michael Jordan, right? He practiced so much. He look at the hoop, right? He threw his basket. Boom. Must be in. Isn't it amazing? Do you think at the time he has to think, oh, I need to be at a 45 angle, 60 angle, 90 angle. Does he have to think about that? No need. No need. That's why that's why we have a guy called Magic Johnson, right? He's doing the same thing, right? Is that magical? What seemed to be magical behind it is a lot of work. In other words, that magic could happen if there's enough work to support it. There's enough work to support that magic. Okay, when I think of Magic Johnson, I often think, why is it called Magic Johnson? Yes, he's doing magic. but he's done a lot of work on himself. Okay, without further ado, I'll see you guys tomorrow. I'm looking forward to tomorrow. We're going to be doing lots of hands-on. We're going to do this together. We're going to enjoy the process, and we're going to see a lot of fun things, but we never have to memorize. Okay, that's what I want you to be able to do. Okay. Well, the end of the class. I'll see you guys tomorrow.
Thank you.
Thank you guys. Good job.